Hello, I'm Brian Young, and today we're going to be taking a look at Module 00106, Introduction to Basic Rigging. Let's get started. Introduction to Basic Rigging. Successful completion of this module prepares you to do the following. Identify and describe various types of rigging slings, hardware, and equipment. Identify and describe various types of slings. Inspect various types of slings. Describe how to inspect common rigging hardware, identify and describe various types of hoists, and identify and describe basic rigging hitches and the related emergency stop hand signals. Performance tasks, your instructor is going to have you demonstrate the proper ASME emergency stop hand signal and demonstrate the ability to report the load capacity of a sling and if the sling is too damaged to use. Overviews as a common activity at nearly every construction site is the movement of material and equipment from one place to another using various types of lifting gear. The procedures involved in performing this task are known as rigging. Not every worker will participate in rigging operations, but nearly all will be exposed to it at one time or another. This module provides an overview of the various types of rigging equipment, common hitches used during a rigging operation, and the related emergency stop hand signal. Basic rigging equipment 1.0.0. Demonstrate the proper ASME emergency stop hand signal. That's the American Society of Mechanical Engineers. They have different hand signals for communicating with the crane operator, and one of those signals is the emergency stop. Anyone can perform the emergency stop hand signal while a lifting operation is going on. Rigging is the planned movement of material and equipment from one location to another using slings, hoists, or other types of equipment. Some rigging operations use a loader to remove materials around a job site. Other operations require cranes to lift such loads. Two common types of cranes are the overhead cranes and mobile cranes. As with other types of equipment, cranes are available in many different configurations and capacities. Let me start by saying you're never going to go onto a job site and they're going to expect you to perform rigging duties. Rigging is something that you're going to have to be trained in. You'd have to go to school to learn to do rigging. You might participate in a rigging exercise where you're asked to bring slings or shackles from one place to another or to help set them up, but you're not going to be doing any of the engineering, so don't worry about that. It's not something that they're going to expect you to know how to do on the job site. Rigging operations can be extremely complicated and dangerous. Do not experiment with rigging operations and never attempt to lift without the supervision of an officially recognized qualified person. There's that term again. A person who, by possession of a recognized degree, certificate, or professional standing, or by extensive knowledge, training, and experience, has demonstrated the ability to solve or prevent problems related to a certain subject, work, or project. So you'd have to go to school to learn rigging in order to be a qualified person. And it says here, warning, although this module provides instruction and information about common rigging equipment and hitch configurations, it does not provide any level of certification. 1.1.0 Slings. During a rigging operation, the load being lifted or moved must be connected to the apparatus such as a crane that will provide the power for movement. The connector, the link between the load and the apparatus, is often a sling made of synthetic, chain, or wire rope materials. And it has a definition here of wire rope, a rope made from steel wires that are formed into strands and then laid around a supporting core to form a complete rope, sometimes called cable. 1.1.1 sling tagging requirements. All slings are required to have identification tags. An identification tag must be securely attached to each sling and clearly marked with the information required for that type of sling. For all three types of slings, the information will include the manufacturer's name or trademark and the rated capacity of the type of hitch used with that sling. Then this is a highlight. It says the rated capacity is the maximum load weight that the sling is designed to carry. Believe it or not, if they rate a sling for 1,000 pounds, they have lifted 4,000 pounds with that sling. They'll multiply it by 4. So any limitations on a sling or a shackle or any kind of lifting equipment, it's been tested to 400% of its lifting capability. If they've lifted 10,000 pounds with it, it'll be rated at 2,500 pounds. So there's a huge margin of error for anything dealing with lifting or flying overhead. Here's an example of a tag that you'd find on a sling. You cannot use a sling with a missing tag. The tags are not made out of paper. They're made out of either leather or metal or some durable plastic alloy. You cannot use any slings that do not have a tag on them. If the tag is missing, the sling has to be taken out of operation. It says, warning, all slings and hardware have a rated capacity or working load limit, the WLL. Rated capacity, or WLL, is defined by the maximum load weight that a sling or piece of hardware or equipment can hold or lift. Under no circumstances should the rated capacity ever be exceeded. Overloading a piece of rigging equipment can result in catastrophic failure. So the following are tagging requirements for synthetic slings: manufacturer's name or trademark, manufacturer's code or stock number, the rated capacity for the type of hitches used, and the type of synthetic material used in the manufacture of the sling. And for alloy steel chains, the tagging requirements are the manufacturer's name or trademark, the grade of steel, the link size, the rated load, and the angle on which the rating is based, the sling reach, and the number of sling legs. The sling reach is a measure taken from the master length of the sling where it bears the weight to either the end fitting of the sling or the lowest point of the basket. Sling legs, parts of the sling that reach from the attachment device around the object being lifted. So wire rope slings need to have a fixed tag that has the manufacturer's name or trademark, the rated capacity in a vertical hitch, the diameter of the rope, and the manufacturer's code or stock number of the sling. 1.1.2 Synthetic Slings. Synthetic slings are widely used to lift loads, especially easily damaged loads. This section covers two types of synthetic slings: synthetic webbing slings and round slings. Web slings provide several advantages over other types of slings. They're often softer and wider than chain or wire rope slings. They do not rust or corrode, and therefore will not stain the loads they're lifting. They're lightweight, making them easier to handle than wire ropes or chain slings. They're flexible. They mold themselves to the shape of the load. They're very elastic, and they stretch under a load much more than wire rope. Loads suspended in synthetic slings are much less likely to twist than those in wire rope or chain slings. You'll see the synthetic slings, the webbing slings, are really the preferred slings out on the job site. Most people now use the web slings. Regulations and site procedures. This information in the module is intended as general guideline. The techniques shown here are not the only methods that can be used to perform a lift. Many techniques can be safely used to rig and lift different loads. So again, this is not the only way to do it. Here's a picture of them lifting a boat. They're using the synthetic web slings, and you can see how the slings will shape to the side of the boat. They'll actually conform to the shape of the thing that they're lifting. For all the advantages that synthetic slings provide, there are some concerns that must be kept in mind when using them. For example, synthetic web slings should not be exposed to temperatures above 180 degrees Fahrenheit. They're also susceptible to cuts, abrasions, and other wear and tear damage. So you do not want to get them near a source of heat. They will melt. Most synthetic web slings are manufactured with red core warning yarns. These are used to let the rigger know whether the sling has suffered too much wear or damage to be used. When the red yarns are exposed, the synthetic web sling should not be used. So here's a picture of a web sling, and you can see the red fibers inside. A lot of times they'll have some red yarn inside the sling, and then they'll have a different color of webbing on the outside, yellow or green. And then if you see any of the red strands, the sling needs to be discarded. You can't use it. It's undergone some trauma, and that's why you can see the fibers inside. Caution: if the sling does not come with protective pads, use other kinds of softeners of sufficient strength or thickness to protect the sling where it makes contact with the load. You can use pieces of old sling, fire hose, canvas, or rubber. Manufactured softeners can also be purchased. Here's a couple of examples of web slings. This is an endless sling. It's just a loop. This one has regular eye and eye ends, and this is a round sling. Endless web slings, which are also called grommet slings. Synthetic web eye and eye slings, which are made by sewing an end of the sling directly to the sling body. Standard eye and eye slings have eyes on the same plane as the sling material. Twisted eye and eye slings have eyes at right angles to the main portion of the sling. They're primarily used for choker hitches. Round slings are made, they're a continuous circle out of polyester filament yarn. The yarn is then covered by a woven sleeve, and the cross section of the web actually looks circular, so they call it a circle web. Here's the standard, here's the twisted. This is the one used for choker hitches. Synthetic web eye slings are also available with hardware end fittings instead of fabric eyes, like this one. Round slings are made by wrapping a synthetic yarn around a set of spindles to form an endless loop. Protective jacket end encases the core yarn. One type of round sling is the twin path sling. Twin path sling is a trademark sling by Slingmax. And here's an example of that. Twin path slings are made of a synthetic fiber such as polyester. The material used to make up the strands and the number of wraps in a loop determine the rated capacity of the sling, or how much weight it can handle. Let's see, I'm going to go on. These are cranes. They're talking about the cranes around the world. The twin path sling. Here's a twin path sling. It's actually two synthetic slings that are parallel to each other. The jackets of these slings are available in several materials for various purposes, including heat-resistant Nomex, polyester, and bulked nylon cover max. Twin path slings feature K-spec yarn, weigh at least 50% less than a polyester sling of the same size and capacity. And there's the twin sling. You can see there are actually two sling strands that are sewn together. Twin path slings are equipped with tattletale yarns to help riggers determine whether the sling has become overloaded or stretched beyond a safe limit. These are those tattletales. They're pieces of yarn that are not used for lifting. They're just loose, and they extend out of the sling. And if for some reason the sling is pulled too long, if it's stretched too far, these tattletales will slip inside the sleeves and we won't be able to see them. So if you have a twin path sling and the tattletales are gone, they're missing, then the sling cannot be used. It's been stretched beyond its capability, its limits. These slings are available with a fiber optic inspection cable running through the strand. So they also have them with fiber optics that you can shine light through. And if it's stretched too far and the fiber optic, the fiber gets broken, then the light won't pass through it. And it'll let you know that that sling has been over stressed and should not be used. The way the sling will be used determines what material is used for the jacket around the sling. Polyester is normally used for light to medium duty sling jackets. CoverMax, a high strength material, is much greater resistance to cutting and abrasions, is used to make a sturdier jacket for heavy duty use slings. 1.1.3 Alloy steel chain slings. Alloy steel chains, like wire ropes, can be used in many different rigging operations. Chain slings are often used to lift in high heat or rugged conditions. Chain slings can be adjusted over a center of gravity, making it a versatile sling. They're also the most durable. However, a chain sling weighs much more than a wire rope sling, and it is also much harder to inspect. Workers will encounter both types of slings in the field, must decide which type of sling is best for each situation. So here is a close-up of a wire chain sling. Each and every link is marked, it's stamped, showing the strength of that link. And what's the old saying? A chain is only as strong as its weakest link. You cannot replace these links. If a chain breaks, it needs to be taken out of service. You can't fix it by putting a shackle on it. The shackles are not rated for as much weight as the chain itself. So that shackle is going to give way and someone's going to get hurt. Single and double basket slings do not require end-fitting hardware. The chain is attached to the master link in a permanent basket hitch or hitches. So here's a single basket hitch, here's a double basket hitch, and they can also make a bridle hitch where the three chains come from the master link and they have end hooks for attaching to the objects being lifted. Most alloy steel chain slings can be used in temperatures up to 500 degrees Fahrenheit with little loss in rated capacity. So they're good when you're lifting something in a high heat environment, or if you're lifting something that's very hot. If it's melted, a bucket of lead or whatever, I don't know. But anything that is high heat, you can use steel chain. Wire rope slings. Wire rope slings are made of high-strength steel wires that are formed into strands and wrapped around a supporting core. While there are many types of wire ropes, they all share this common design. As a general rule, wire rope slings are lighter than chain, they can withstand substantial abuse, and are easier to handle than chain slings. They can also withstand relatively high temperatures. That's highlighted. So the steel wire slings are made from strands that are wrapped around a center core, just like a rope. These are wire rope. The supporting core enables the strands to keep their original shape. There are three basic types of supporting cores for wire rope. I don't think you have to have these memorized. You can have a fiber core, or you can have an independent wire core, or a strand core. The strand core uses a strand the same size as the strands that make up the wire rope itself. On the inside is the core. This fiber core is actually a synthetic fiber, a synthetic nylon or some kind of a core that the steel strands are wrapped around. Fiber core ropes, for example, may be damaged by heat at relatively low temperatures of 180 degrees Fahrenheit to 200 degrees Fahrenheit, as well as by exposure to caustic chemicals, because that core is susceptible to heat and chemical. 1.2.0 Sling Inspection. Rigging operations can be dangerous even in the best of conditions. If equipment failure occurs, the results can be devastating. Since slings are commonly used to connect loads to lifting equipment, they're susceptible to wear and damage. To ensure that slings are safe to use, it's absolutely critical that they be thoroughly inspected on a regular basis. Inspections must be conducted regardless of any existing markings or tags that are related to previous inspections. So before every use, someone's going to take a look at that sling. It might be you. You don't have to be a qualified person or a competent person to look at the sling and just look for damage. If anything stands out, you need to take the sling to a qualified person and let them make the call whether that sling can be used or not. But you can look at the sling and look for any defects, look for any breaks in the strands, or if it's a chain sling, any elongation of the links, any crushing of the links or bending of the links, if they've got stuck or wrapped around something and bent, then that chain sling needs to be taken out of commission. 1.2.1 Synthetic Sling Inspection. It says, like all slings, synthetic slings must be inspected before each use to determine whether they are in good condition and can be used. They must be inspected along the entire length of the sling, both visually, looking at them, and manually, feeling them. If any rejection criteria are met, the sling must be removed from service. Warning, it says a competent person must inspect synthetic slings before they're used every time. The inspection must involve a visual and a touch examination. Sometimes defects and damage can be seen, other times they can be felt. If any synthetic sling meets any of the rejection criteria presented in this section, it must be removed from service immediately. In addition, the rigger has to exercise sound judgment. Along with looking for any single major problem, the rigger must also watch for combinations of relatively minor defects. So here are some of the things that they're looking for. If this is a synthetic sling, jacket and web abrasion, jacket and web sling that have been cut, minor abrasions, if the jacket is cut, if other jacket cuts. Here's an example of a cut on the edge. This looks like a cut with warning threads showing. Tensile damage, they have friction burns. Here's overload damage, the tattletales are pulled out. Severe heat damage, or one-ply penetration or exposed yarns, any of those. And if any of those are present, the sling needs to be discarded or taken out of service. Here's the very first rejection criteria is a missing identification tag or a tag that cannot be read. Every sling that is used on a job for lifting has to have a current tag, and it has to be legible. So if the tag is missing, if the tag's been taken off, the sling has to be taken out of service. Any synthetic sling without an identification tag must be removed from service immediately. And then they have abrasions or cuts or tears, a puncture, broken or worn stitching, a knot that cannot be removed by hand, a snag in the sling that reveals the warning yarns, crushing of either a web sling or a round sling, damage from overload. And twin path slings have tattletale features. When the tattletale has been pulled into the jacket, it indicates that the sling may have been overloaded. Chemical damage or heat damage or ultraviolet damage, loss of flexibility, any of these are criteria for taking the sling out of service. Alloy steel chain sling inspection. Alloy steel chain slings must be carefully inspected before each use to determine if they are safe to use. There are numerous rejection criteria that indicate when an alloy steel chain sling must be removed from service. And here are some of those examples. Heat damage and cracks, overload damage, impact damage or bent links, twisted links, excessive wear. On this one, if you look closely, you'll see how narrow the links get on the ends. So that's overloading. Cuts, chips, and gouges, rust and corrosion, any of those reasons. And again, the very first criteria is missing or illegible identification tag. Cracks, heat damage, stretched links, bent links, twisted links. Just take a chain sling out of commission. Sling jackets. It says if only the outer jacket of a sling is damaged under the rejection criteria, that sling can be sent back to the manufacturer for a new jacket. It must be tested and certified by the manufacturer before it can be used again. It's much less costly to do this than to replace the sling. However, slings that are removed because of heat or tension-related jacket damage cannot be returned for repair. It must be disposed of by a qualified person. Wire rope sling inspection 1.2.3. It says, like other slings, wire rope slings must be inspected before each use by a competent person. Remember, a competent person is defined by OSHA as a person who is capable of identifying existing and predictable hazards in the surroundings or working conditions that are unsanitary, hazardous, or dangerous to employees. And there's that word and who has the authorization to take prompt corrective measures to eliminate those conditions or to shut down the job. They have the authority. If the wire rope is damaged, it must be removed from service. And here this is highlighted. Only a competent person can decide whether to use a wire rope in a rigging operation or discard it if it is damaged. Any worker who suspects the wire rope sling may be damaged must bring it to the attention of the competent person, stopping the activity lift if necessary to do so. If a wire rope sling is simply missing its tag or the tags become unreadable due to wear, it can be re-tagged by a qualified person. Remember that the qualified person is defined by OSHA as a person who, by possession of a recognized degree, certificate, or professional standing, or by extensive knowledge, training, and experience, has demonstrated the ability to solve or prevent problems relating to a certain subject, work, or project. So here are common types of wire rope damage: broken wires, kinking, bird caging, crushing, corrosion. Bird caging is when the wire rope was under tension and the load swung. It revolved and it unwound the strands of the rope, of the wire rope. They don't go back together again correctly, so it makes what's called a bird cage. Then it says common types of wire rope damage. Broken wires, they'll count how many breaks are in one lay of the rope. Rejection criteria for broken wires consider how many wires are broken in one lay length of rope, or one rope lay. One rope lay is one strand going 360 degrees around that rope. So when one strand has completely circumnavigated that rope around the outside of it, the circumference of it, that's one rope lay. And it's different lengths for different ropes. So in that one rope lay, I think if there are 5 or more breaks of strands, individual strands, then it has to be taken out of service. You can have 1 or 2 broken strands in a lay. Kinks, kinking or distortion of the rope is a very common type of damage. Kinking can result in serious accidents. Bird caging, this damage occurs when a load is released too quickly and the strands are pulled or bounced away from the supporting core. The wires in the strands cannot compensate for the change in stress level by adjusting inside the strands. Unstranding. Unstranding describes a wire rope strands that have become untwisted. This weakens the rope and makes it easier to break. Signs of core failure, crushing, corrosion and rust, heat damage, integrity of end connections, any of those are reasons to take wire rope slings out of service. Here's a warning. They say broken wires in a sling are extremely sharp and can easily cut or puncture the skin. Never use a bare hand to handle wire rope slings or to inspect them by running a hand along their length. That's very good advice.